This presentation is on sampling distributions, but this time it's on proportions. So we're looking at populations, and it's going to be categorical variables, but we're turning it into proportions. The last one that we viewed was on means. Proportions from populations and from samples. We have two different things going on. We have a population proportions, and that's a parameter. It's denoted by P. And then we're mainly dealing with sample proportions, because ideally we're not going to find the population proportions. We're going to have to estimate the population proportions by getting samples. So a sample proportion is a statistic, and it's denoted by p hat. And if you didn't already know it, that the p hat is the count of successes in a sample over the size of a sample. Actually, you kind of learned that probably in elementary school, how to calculate a proportion, or percent. But in statistics, we call it the capital X over N, where N is our sample size. Means and standard deviations of proportions. The mean of a proportion in the sampling distribution is exactly P, what we get from the population. Most of the time we don't know that, but in the next few instances we will be given P, and we'll be using that particularly when we use our normal distribution formula, z-score. So anyway, the mean of a sampling distribution of a normal curve is exactly P. The standard deviation formula is given by the square root of P times 1 minus P over N. And notice that as N gets bigger, our standard deviation gets smaller. And very often we'll see the question asked, what kind of sample would it take to cut the standard deviation in half, or by thirds? And so notice that the N is underneath the square root symbol. So in order to take half of the standard deviation, so imagine 1 over 2 on the outside, we need a population size 4 times the sample size of N, okay? Because the square root of 4 is 2, so that would be how we get our half. Expect that question to be asked, because it's asked very often, what kind of sample size would you need to cut the standard deviation in half or by a third? Okay, and in this particular section, we have 2 rules of thumb now. We are not allowed to use the standard deviation formula that we had earlier, the standard deviation formula, unless our sample size is at least 10 times, our population is at least 10 times as large as our sample. So sometimes we just have to estimate it. Sometimes we have to guess. If we were looking at the women voters in a certain city, we would know that the population of women voters in the United States is 10 times greater than that. So sometimes it's kind of ambiguous, and we have to just assume that the population is 10 times greater than the sample size. Other times it's given. And then for us to be able to use a normal approximation, just like we were using for means, we have to use N times P is greater than 10, and N times 1 minus P is greater than 10. Now note that they call this, in this particular section, this condition rule of thumb number 2. It was rule of thumb number 1 in the last section. I don't like calling it rule of thumb number 1 or 2. These are just conditions that have to be satisfied in order for you to be able to use the standard deviation formula or to use a normal approximation. So rather than remember it as rule of thumb number 1 or 2, remember it as conditions that allow you to use something for finding proportions and to assume normality. Alright, and this is the last frame. Things to remember about proportions. The p hat is the proportion that is from a sample. A sampling distribution of proportions is made up of many p hats, and the center or the mean of the sampling distribution is p, the population parameter, that proportion. Although we usually don't know it, and we'll do our best to estimate it, and we'll spend the rest of the semester learning how confident we are that that estimate is accurate. If the population is 10 times greater than the sample size, we can use the standard deviation formula, and if N, P, and N times 1 minus P, if they be greater than or equal to 10, then we can use the normal distributions. Okay? Please review this, take notes on this, and answer the questions that are assigned. Thank you.